All right, an unnecessarily difficult Faraday's law problem, right? Okay, so basically we're going to do that the EMF is equal to, and then the rate, the IV symbol over T, right? This is Faraday's law. So the rate change of magnetic flux divided by time, which ultimately boils down to NBA over T, right? Now the trick here is to figure out what the change in flux is. And so here's something that's level. Here's this loop that's like at a 75-degree angle. And we're seeing it from the side, so we can't see through the loop because we're seeing it perfectly from the side. But it's going to apparently go from starts at this angle and goes to this angle. So, and the magnetic field is into this page, right? So let's draw that. How about cyan? What the heck is cyan? So the magnetic field is a deep draw on the magnetic field, right? I'm looking at the page from the side here. Okay, I can't deal with cyan now. All right, and so what's happening here is we are going to gain flux into the page, right? If we gain flux into the page, that is, right now there's not very much flux. Not very many of these lines go through the loop, as you can see, because we're seeing the loop from the side here. Not very many go through, and more will go through the loop when it falls down. So we're gaining flux into the page, and the way you fight that is, of course, you're going to go anti-clockwise because that will create flux out of the page, right? So anti-clockwise is definitely the direction. And what's happening here is the angle is changing, right? It's cos theta, right? Okay, but nothing else is changing. The windings, there's only one winding, right? The magnetic field is 6.95 Tesla as well. That's pretty strong. The area is just pi r squared, right? And then it's the cosine that's changing, right? Okay, now since there's a undefined minus sign in here, and then there's other minus signs here, just take the absolute value of it because we've already figured out the direction it's going, right? And the minus sign would have just given us that direction if we had some sort of vector calculus way to do this, right? So let's just figure this out. It's 1 is n, b is 6.95. Area is pi times 0.43 squared. And then it's cos, let's see, final minus initial. So cos 0 minus cos 75. All right. Remember, cos 0 is 1, so just be careful. All right, so you end up going 1 minus cos 75. All right, so 6.95 times pi times 0.43 squared times, they're all the same though, they're all cos 0. Okay, let me check my mode. I am in degrees, okay. All right, let's go. It takes me to the beginning of the expression. How silly. Minus cos 75. All right, so now divided by the time. Forgot to divide by the time. How long does it take? 0.005. All right, divided by 0.005. 598.447. volts, and it'll go anti-clockwise because it's fighting. It's an increase of flux into the page, so we create flux out of the page. Create flux out of the page. Flux into the page increases, increases. All right. Yeah. Happy hunting.